Nope. Yep. Nope.
Hello, Math Files. Welcome to MWW Math Empire, where numbers talk. Previously, we've treated Intro to Probability, where I gave an overview of what probability is all about. In this video, we are going to continue with the second episode, and here you are going to learn how to solve these following questions. All right, but just a brief recap. I want you to know that the probability of any event happening lies between 0, which is less than or equal to x, which is also less than or equal to 1. This very expression here simply means that it must be between 0 and 1, or it can be 1, or it can also be 0. Anything that is greater than 1, there must be problem somewhere. That means it's not probability. Do you copy? All right. Now, when you look at this, I want you also to know that this very x here represents the probability of any event happening. Now, the probability of obtaining success plus probability of obtaining failure is equal to 1. Permit me to continue from here. If I decide to make this subject of the formula now, the probability of success will be 1, while this will cross over, subtracting the probability of obtaining a failure. If I decide to make this one also subject of the formula, I'm going to have this equal to 1 minus the probability of obtaining a success. So this is just something that I said that you really need to know before I proceed to today's events. All right. The first question reads, when a coin is tossed once, what is the probability of obtaining a head? Okay. Now, the first thing that you need to ask yourself is, what is the total outcome of the event, or what are the total outcomes? Another word for that total outcome is sample space. So each sample space will be equal to head. Since we are talking about coin, you either have a head or a tail. So we have head and we have what? Tail. This implies 2. That means the total outcome here is equal to 2. Now, since the question reads obtaining a head, how many head do we have there? 1 is going to be equal to 1 over 2. As simple as that. This is the answer. Now, even if what we have here is tail, it will also be 1 over 2 because the sample space is just 2 and we are having it either head or a tail. So even if I'm obtaining a tail, it's also going to be 1 over 2. And that will make the events to be equal likely events. And when you say that events are equal likely, it means that both of them have the same chances of what? Obtaining. They have equal chances. But because they have equal chances, doesn't mean that when that coin is tossed, let's say 10 times, that you either have a tail 5 and you have a head also 5 times. That is for them to be equal. No, it doesn't work that way. You can obtain a head 8 times or 9 times while obtaining a tail only a time. Do you copy? So when you say that events are equal likely, it's just the way you are looking at it here. Both of them, you either have this 1 over 2, you either have this 1 over 2. They have equal chances of what? Obtaining. Just like Chelsea, Man U. In my own view, in my own point of view, I will say that these two clubs that I've mentioned now, Manchester United and Chelsea United, both of them have equal chances of what? Winning in any match. They have equal chances of winning. My own view anyway. All right, so let's continue with the second question. A fair coin is tossed twice. What is the probability of obtaining at least 1 head? In this place now, once it has crossed once, we make use of what is called the probability tree. I will solve this in 2 places. I will solve using probability tree and also using its table. So permit me to solve it here. Now, when you say this probability tree, the coin is tossed once. The first one tossed, we obtained a head and a tail. For the first time, it was tossed. Now, twice, we obtain again a head and what? A tail. Because it's twice, a head and a tail. If it is more than two, I will also inscribe this here and also inscribe here and as well inscribe the other down there. Do you copy? All right. Now, because I'm having this, now let's count it. We want to obtain the sample space first. Remember, what you need to know first is the sample space. And I will be having head here. This and this. Head and tail. Head and tail. I will come over here. Tail and head. A tail and head. And I will have here again a tail and a tail. Now, I know that the sample space is now equal to 4. Now, let's go back to the question. It reads of obtaining at least one head. When you hear at least, it means that it is from that very point you are being asked of. That same point and above. But when you hear at most, it means that that point of concentration and below, that is at most. So when I say because the question reads at least one head, it means that anywhere I see one head, I will circle it, and anywhere I see more than one head, because I said above, I will also do what? Circle it. Therefore, I will circle this. I can circle this. I can also circle this, but I will not circle this because I don't have any head here. Hence, the answer will be equal to 3 all over 4. We have solved it now. Now let us move to the table. If you want to use table, if you prefer this, you can be using this one. So it all depends on your choice. Yeah. So now we have a head and we have a tail. We have a head and we also have a tail. Probability. So when this goes here, we have a head and a head, a tail and a head and a tail, and a tail and a tail. Remember what I said? Once you have it in this way, because it reads at least, that point of concentration and above. So now I'm going to circle this. I can circle this. I can as well circle this. We have obtained the sample space as well, which you can see. So the answer will also be what? 3 all over 4. As simple as that. All right. I know that some of you in their secondary school days, or some even at the university level, especially year one, when they see some of these things, they don't normally understand that. Feel free to let us know for more concentration on you because we are open for Zoom lessons. Now, let me use this space for the number 3 question. A fair die is tossed once. Okay? What is the probability of 3 showing up? We are now talking about die, no more coin now. And you know that when you say a die, is a say is singular, is its plural is dice. Dice. All right. So, what are the sample space or the total outcome whenever die is involved? Mind you, to some of you that are hearing this, die is the seed of the Ludo game that we used to play at home. So let's move. We have 1, 2, 3, 4, 5, and 6. This is the total outcome of a die. You either obtain 1, 2, 3, 4, 5, and the highest is 6, which is popularly known as what? Siki. Fine. So now, in this, since we've gotten this, we are looking at the probability of obtaining 3. Now you ask yourself, how many 3s do we have here? Is 1, right? So I don't want you to look it in this way, that since you are having 3 and the formula for probability is possible outcome all over. Let me write it again. So the possible outcome, which the probability you are looking for, will now be 3, and the total outcome will be the 6. No, don't look it in that way. You only count it as what? In a digit. So what we have here is what? You can only obtain 3 once. And even that there are so many chances of obtaining 3, you can now say it is 3 all over what? 6. Hence, this will now going to be equal to 1 all over 6. As simple as that. All right, expect also more videos on this probability. This is just the second episode. Expect the third episode. Remember to like, comment, and share. Inform kids, secondary school, to inform them about this very channel, MWW Math Empire. We are on Facebook, we are in TikTok, we are also in YouTube, we are also on Instagram. So feel free to chat us up and as well bring questions for us. Thank you and God bless you.
Nwanne inu dị egbe malụ n'anya pụgo